Somewhere out in deep space, a star dies. Not in a slow, peaceful way, but violently. So violently that for a few seconds it becomes one of the brightest events the universe can produce. And when it happens, it doesn't send out a normal explosion. It fires a beam, a narrow jet of radiation so powerful, so concentrated, that if it ever pointed at Earth, it could wipe out life without even physically touching the planet. No asteroid, no impact, no warning sirens, just a flash of energy crossing space at the speed of light. And then, everything changes. This is a gamma ray burst, and it might be the closest thing the universe has to a planet-level delete button. Gamma ray bursts, GRBS, are the most energetic explosions we've ever observed. In just a few seconds, they can release more energy than our sun will produce in its entire lifetime. That's not an exaggeration. It's one of those facts that sounds fake until you realize how absurdly large and violent the universe really is. Most GRBS come from dying stars, but not just any dying star. We're talking about stars so massive that when they collapse, they don't form a normal neutron star. They collapse all the way into a black hole. And in that final moment, when the core implodes, the star can fire two massive jets out of its poles. Those jets are the gamma ray burst. And here's the part that makes this terrifying. It's not like the energy expands in all directions evenly. It's aimed, like a cosmic flashlight, except the light is radiation strong enough to rip apart the chemistry of a planet. So if you're not in its path, you're fine. But if you are, you're done. If a gamma ray burst hit Earth, the first thing you'd expect is fire. But that's not what happens. The first thing it attacks is the atmosphere. Gamma radiation hits so hard that it starts breaking apart nitrogen and oxygen molecules in the sky. And that triggers chemical reactions that shred the ozone layer. And the ozone layer isn't a nice extra. It's the reason the sun doesn't cook us alive. It blocks the worst ultraviolet radiation. So once that layer is damaged or destroyed, the sun becomes a weapon. Not because it changed, but because Earth lost its shield. Within hours, the surface becomes dangerous. Within days, it gets worse. The oceans start dying from the top down. Plankton, the foundation of marine life, begins collapsing. And once plankton collapses, the rest of the food chain follows behind it. Fish, birds, everything. Plants on land start struggling too. Crops begin failing, and the world slowly begins to feel wrong. Like the environment itself is turning against life. But that's only the first punch. There's a second effect that's even nastier. As the atmosphere gets hit, it can form a thick brown haze of nitrogen dioxide, which blocks sunlight. So imagine the planet losing ozone protection, and then being thrown into dim, cold darkness. It's like a cosmic 1-2 combo. First radiation exposure, then global cooling, a kind of space-triggered winter. And this isn't just theory for entertainment. Scientists have run models on it. A powerful enough burst from close enough distance really could trigger conditions similar to mass extinction. So, would humans die instantly? Maybe not. And honestly, that might be worse. Because instead of a single dramatic moment, it becomes a slow collapse. Not everyone drops dead in the streets. Instead, society begins falling apart. Food systems fail, supply chains collapse, power grids become unreliable, medical systems overload, governments scramble. And while everyone is trying to survive, the world continues getting harsher. Sunlight becomes more dangerous. The skin burns faster, cancer rates spike, animals die in strange patterns, and the ecosystem keeps unraveling. It wouldn't be a movie apocalypse. It would be quiet at first, confusing. Then it would snowball into something humanity has never had to face, a planet that is no longer safe. Now here's the question everyone asks. How likely is this? Should we actually be worried? The good news is, gamma ray bursts are rare, and the really dangerous kind, the long-duration bursts caused by massive collapsing stars, usually happen in galaxies with lots of star formation. Our region of the Milky Way is relatively calm, so no, this isn't something you should lose sleep over every night. But the uncomfortable truth is, it doesn't need to be common, because it only has to happen once. The entire threat of a gamma ray burst isn't the frequency. It's the fact that the outcome is absolute. If one happens close enough and aligned with us, it could reset life on Earth. And the scariest part? We wouldn't see it coming. Because gamma rays travel at the speed of light, meaning the warning arrives at the same exact time as the burst itself. There is no early notification, no countdown, no chance to prepare. One moment everything is normal, and the next, Earth is hit with an invisible cosmic beam. And after that, we deal with the consequences for years, decades, or we don't deal with them at all. There's something deeply unsettling about that. Gamma ray bursts don't feel like a threat the way other threats do. There's no enemy, no decision, no evil villain, just physics. And in a universe this big, physics always wins. A gamma ray burst is a reminder that Earth is not protected. We're not isolated from danger. We're simply lucky. And we've been lucky for a very long time. So the next time you look up at the sky and it feels peaceful, remember what's really happening out there. Stars are dying all the time. Most of them die quietly. But every now and then, a star dies in the wrong way. And if that beam ever points at us, we won't get a final warning. We won't get a last message. We'll get a flash and then silence.